Hi folks, Chris McClure. We will now talk about assessing normality and the fact that, or at least the assumption that your data set comes from a normal distribution underlies a lot of the tests that we do. So we're going to talk about how to determine whether the set of numbers that you have could conceivably have come from a normal probability distribution. That's what we're going to talk about, how to determine that. Visual inspection of a histogram to see if it's roughly bell-shaped. Well, that's one way of doing it. You get your set of numbers and you construct a frequency distribution followed by a histogram. And if it has a roughly bell-shaped aspect to it, then that's one way of identifying it. Here's yet another way, is constructing what we call a normal quantile plot, sometimes called a QQ plot, as another way of determining whether the data are somewhat normal. So a normal quantile plot, sometimes called a normal probability plot, sometimes called a QQ plot. It's a graph of points x comma y, where each x value is from the original set of sample data and each y value is from a corresponding z-score that is a normal quantile value expected from the standard normal distribution. Moving along here. So here's the procedure for determining whether it is reasonable to assume that your data could conceivably have come from a normally distributed population. Number one is to construct that histogram that we mentioned earlier and see whether that histogram is somewhat bell-shaped. If there are more than about one or two outliers present, then you should probably reject the assumption of normality. And then the third thing to do is to construct that QQ plot. Now, a lot of people automatically go straight to constructing the QQ plot, but in reality, you should first do the histogram, then identify any outliers, and then do the quantile plot. Only if the histogram looks somewhat like a bell curve, and if there aren't very many outliers, then you should go to constructing the normal quantile plot. And I'll show you how to do it using StatCrunch. So, what to look for on the QQ plot / quantile plot is to look to see if the pattern of points is reasonably close to a straight line and the points do not show some sort of systematic pattern that is not a straight line pattern. Okay? You'll see an example here in a minute. Now, when you're looking at your quantile plot, here are two things to see if, your population is not normally distributed. Number one, the points do not lie reasonably close to a straight line, or the points show some sort of systematic pattern that is not a straight line pattern. Okay? If one or the other of those conditions are met, then you probably have not sampled from a normal population. So here's an example. Suppose that we have a sample of IQ scores, and we've constructed the histogram. You notice it's bell-shaped somewhat, and you don't see all that much in the way of outliers, right? And then here's an example of the normal quantile plot. And notice that you see these dots generally being along a straight line. So it's safe to assume that the IQ scores are from a normally distributed population based on what we see here. Now here we've sampled from a uniform distribution. And notice the pattern of the dots. Now they're not too far from being linear in nature, but you see that there's kind of a sinusoidal pattern. Because of the fact that you see a sinusoidal pattern, that right there suggests that the data do not come from a normal distribution. Here we've got a sample from a highly skewed distribution. You can see that from the histogram, and here's what the normal quantile plot looks like. Certainly the points do not lie along a straight line, not even close. All right. So if you had to do this by hand, which by the way I don't expect for you to do, here's how you do it. I'll just talk you through these steps. First, sort your data from smallest to largest. Step 2, with the sample of size n is the sample size, each value represents a proportion of 1 over n of the sample. So if you have the sample of size 100, then each number will be 1/100th of the data set. Using the known sample of size n, identify the areas of 1 over 2n, 3 over 2n, and so forth. So for example, if the sample is of size 100, then you would be identifying areas of 1 over 200, 3 over 200, 5 over 200, 7 over 200, ... And these are the cumulative areas to the left of the corresponding sample values. And you do the division. 1 divided by 200 is, whatever, 0.005, etc. And then use the standard normal distribution, either using the table or software or calculator, to find the z-scores corresponding to the cumulative left areas found in step 2. In which I've shown you how to look up those areas in the past, and then you work backwards to find the z-scores. And then you'll match the original sorted data values with their corresponding z-scores. Then plot the points where each x is an original sample value and y is the corresponding z-score. And then you'll examine that normal quantile plot. You can do this strictly by hand with the help of a calculator. You can use this using Excel to help you with your computations and organization. I'm going to talk about these other ones real quick, but I'm going to show you how to use StatCrunch, which is really what I want you to use. So what I've done is I've gone into Course Compass, aka My Stat Lab, and pulled up one of the homework assignments from section 6.6, in which they're asking you to generate a normal quantile plot. Folks, use technology here. This is the 6th problem from section 6.6. I'll show you how to use StatCrunch to generate the normal quantile plot. Let's go ahead and open up the data set here by clicking on this icon. And then we'll click on this icon right here and to open it up in StatCrunch. So there, we've opened the data set up in StatCrunch. We have this one column of the data values, and we want to generate a QQ plot. Here's how we do it. We'll go up to the top row of menu buttons, click on Graph, and then go down, click on QQ plot. And then select on the column label, variable 1 in this case, and you can ignore everything else. Just simply click on compute, and there is the quantile plot. Now, actually, they have this rotate at 90 degrees compared to how the book is telling you to generate. It doesn't really matter. All you're really looking for is to see whether your dots follow a linear pattern that is not in a systematic sort of pattern that is not linear. Here you can see these dots are in a somewhat sort of sinusoidal sneaky shape like you see here. That right there is enough to tell you that this data set does not come from a normal probability distribution. Now, if these data points were randomly arranged above and below a line and in a straight line sort of pattern, then that means that the data set would be or would have come from a normal probability distribution. In this case, that's not the case, though. This is not from a normal distribution because of that sneaky pattern. Okay, so I just want to show you how to use StatCrunch to generate your normal quantile plots. If you're interested, you can open up Excel and go into the help menu and have it show you how to generate normal quantile plots. Not too hard. And there are various utilities available through the internet too. If you go to Google or Yahoo or Bing or any other search engine and type in online normal quantile plot utility, something like that, and you'll be able to pull something up to help you. Okay, folks? So going back to the slideshow here, you could have your software give you a numerical value as to, to what degree is your data normal. The Ryan Joyner test is one of them, and which I'm just going to leave it at that. More information in your textbook. You won't need to know much about that. Data transformations, if your data is not normal, but you still need to be able to do some work with your data set in which you have to use that assumption of normality, but you know darn well that your data is not normal. One thing that you could do is you can do a data transformation by using some function like, for example, a logarithm. Like you see here, is replace each value of x, for example, if x is the data value from your set, and then take a log base 10 of x plus 1. And really, the base of the logarithm doesn't matter. You could do natural logarithm if you want. And then to generate a new data set. And then determine whether your new set of numbers, which are the log of x plus 1, is now normal, and it should be, if it wasn't already. And if that is the case, that your new set of numbers is normal, then you'd have a log normal distribution. So how do you do that? You can go back up to here, open the StatCrunch, and you could have StatCrunch helping. And I haven't practiced this ahead of time, but let's see what we could do. We can compute an expression, build, let's see here, we can go down and take logarithm, and then within the logarithm we can click on that column variable 1, and then we'll do plus 1, and then compute. And then let's see if this column of numbers where each number is where we took log of the number in the first column plus 1. So this 3.3672958 is the log of 29. And 5.9532433 is the log of 385, etc. Now let's go back to the graph, QQ plot. Let's see what happened here. QQ plot. Excuse me. Something's happening. I got to figure it out here. Let's go into graph. So having a little technical difficulty. But you click on QQ plot, and we'll select on that new column that we generated. Unfortunately, this didn't help us out. Sometimes doing a transformation will give us a normal sort of shape. In this case, it didn't. Okay, maybe some other transformation involving an exponential or sine or arc sine or some other transformation of functions that you learned maybe from algebra or trigonometry could transform your data into a set that is normal. And, as you could see, I was not successful in that case, but try some other functions so besides the logarithm. Okay. But I just showed you one common transformation. There's many others to try. You could also try square roots, reciprocals, squares, etc. In addition to getting a required normal distribution when the original data values are not normally distributed, such transformations can be used to correct other deficiencies, such as a requirement that different data sets have the same variance. Okay, so with that, we are done talking about how to assess normality. The short answer is you are about to do some sort of test or procedure in which the assumption is that the data came from a normal distribution. Well, before you go any further, let's check that assumption by constructing the histogram, if you haven't done so already, and look for that bell shape. Look to see whether you have a lot of outliers. And then construct the QQ plot, aka normal quantile plot. Okay? Well, I'm going to record another video here in a couple minutes for section 6.7, and I'm going to record a lot more videos. I'm going to be out of town on vacation for about a week, so I want to make sure I get these videos front loaded. So I'm going to actually try to record all videos to get us through chapter 8 by Tuesday before I leave. Okay? So have a good day. If you haven't taken your test, which most people have, but if you haven't taken your midterm test, please do so right away. Have a good day, folks.